Hello, Math 6. This is a lesson for equivalent ratio practice using horizontal ratio tables. So we're going to do a series of 6 problems using horizontal ratio tables. And if you'd like to work along with me, that would be great. Our first one here, we each have these numbered, so we're going to go through 6. If you look down here, I also have a checklist of steps I should be asking myself as I work through these problems. So I'm going to first draw a ratio table and label it, put in the ratio, and then ask myself, can I make my ratio more friendly? Can I simplify it to make it more usable with multiplication and division? And what do I need to end up with? What am I trying to solve for? So looking at those steps, I'm going to go ahead and do my first one. Is I'm going to draw a ratio table, and then I'll label it after I've read my problem. So here's my T. It's a T chart. It'll end up being a ratio table. Lena is training for a race. The ratios of the number of minutes she runs to the number of miles she runs is 35 to 5. She plans to run 20 miles. How many minutes will it take her? So the first thing I need to think about here are what are the two things I'm comparing? So a ratio is comparing two quantities. So what am I comparing here? If I read back in my problem, I can see it's the number of minutes and the number of miles. So I've highlighted those. Okay, so I'm going to go ahead and insert that first ratio, which is 35 to 5 in here. So we're going to do minutes to miles. So I'm going to start with 35 to 5. Ta-da! So we have done that first checkbox, and we've also put in our ratio. Now we're going to ask ourselves, can I make my ratio more friendly? Is there an easier ratio that I can use with multiplication and division in working with my problem? So what I'm going to do first is look for a greatest common factor. So what can go both into 5 and 35? Well, I know 5 can go into 5, and 5 also can go into 35. So I'm going to divide by 5, on the top and the bottom here to get an equivalent ratio of 1 and 7. So 7 minutes to every 1 mile. Okay. Now I'm going to look at the next part of my ratio table. This goes to the last question. What do I need to end up with? Well, it tells me that she plans to run 20 miles. So I'm going to go ahead and put 20 miles in there. What I'm asking for is how many minutes it's going to take her to run that 20 miles. So now that I have a friendlier ratio, I can go ahead and figure it out. I know that 1 times 20 makes up 20. And what I know about equivalent ratios is what I do to one quantity, if I do to the other, I will come up with an equivalent ratio. So I'm going to multiply that 7 also by 20 to find out the minutes. If you can't do that in your head, totally fine. I usually just look at this as 2 tens. So 7 times 2 tens is 14 tens. Oops, let's do that in a black marker. 14 tens. Okay, if you need to write it out, never feel ashamed that you have to do that. That is totally okay. So 7 times 0 is 0. 7 times 2 is 14. Okay, and so we have our answer. It'll take her, Lena will run 20 miles in 140 minutes. She is a quick lady. All right. Looking at the next one, it says a chef is planning for a large dinner party and thinks that 2 out of every 6 guests will order salad. If there are 360 guests, how many salads should the chef prepare? So let's start off by making our ratio table and labeling it. Okay, so looking at my table, and I need to figure out how to label it, I'm going to look back into my problem, and what two things am I comparing? I'm comparing ordering salad and how many guests there are. So I'm going to just go ahead and write, these are my salad people, and these are going to be my guests total. Okay. Now we can go ahead and put in our original ratio, which is 2 out of every 6. So 2 people out of every, I don't want purple. 2 out of every 6 guests are going to order salad. Okay, let's try to make this a friendly ratio. So that's my next step. Can I make this a friendly ratio? Now, 2 to 6 is a pretty doable ratio. You don't have to do this step, but I still think that making it a little more simple it goes a long way in trying to find out your eventual total. So let's go ahead and look. What can I divide 2 and 6 by to make an equivalent ratio? Well, I know 2 can go into 2 and it also can go into 6. So I'll use that number. So we'll have 1/3. The good thing about using a more simple ratio is when I have this 1, when I go to do that next multiplication, 1 times anything is going to be what you're multiplying it by. So that's helpful. Okay, so I've made this more friendly. Now let's look down. What do I need to end up with? We want to know how many salads this chef should prepare if we have 360 guests. So we're trying to find out how many salads here. Now what I'm going to do is I'm going to figure out, what do I multiply times 3 to get 360? Once I figure that out, I can do it up here to make it equivalent and find out my missing value. So I'm going to make a long division problem over here in this lime green. I know that I need to figure out how many times 3 goes into 360. So 3 goes into 3 one time. We're going to bring down a 6. 3 goes into 6 2 times. And then our last value, 0, goes in 0 times. So we have 120. Oops, just kidding, wrong spot. It's being multiplied 120 times. So I need to do that to the same one up here. Now, since we have this friendly number, 1 times 120, I can just go ahead and put in 120, and that's my answer. So the chef will prepare 120 salads. Ta-da! Now this next one is a little tricky. This one is normally we've been looking at part-to-part relationships. This one kind of takes it to a part-to-whole relationship. So I'm going to draw a picture here just to get started. I'm going to go ahead and use red for strawberries, and then I will use yellow for bananas. So it says Franco is making a fruit salad. The ratio of cups of strawberries to cups of bananas is 2 to 4. So I have 2 bananas for every 4 bananas to strawberries, right? So this is my recipe here, 2 to 4. Now I'm looking at it, how many cups of fruit is there all together? There's 6 cups, right? So if I were to make a ratio of strawberries to the whole recipe, it would be 2 to 6. If I wanted to find out how many bananas, it would be 4 to 6 because I'm doing a part to whole, okay? So let's go ahead and start by drawing our ratio table, and we're going to write what our labels are here. So looking at my problem, it tells me how many cups of bananas, so I'm looking at bananas, sorry, let me do that in yellow. How many bananas will he need to make 48 cups of fruit salad? So I'm comparing bananas to fruit salad. So I'm going to go ahead and write that in there. Oops, I keep using the wrong marker. Okay, so we will do bananas to fruit salad. Okay, and then we're going to put our first ratio in. So in looking at my first ratio, I know I'm talking about bananas. So I'm going to look at the banana value, which is right here. I have 4 bananas. Then it's asking me to compare it to the fruit salad total. And I know because I've added these together that I'm comparing it to the 6 cups all together. So if I put 2 cups and 4 cups together, I would have 6 cups, which is 1 set of fruit salad. Okay. Now we're going to go down to our next spot. Can I make this a friendlier ratio? You can't, 4 to 6 is also doable like the last one, but again, it doesn't hurt to make it a little bit more simple on ourselves. So what number can go both into 4 and 6? Sorry, that's a division symbol there. I know that 2 can go both into 4 and 6, so I would have 2/3 as my next ratio. Now I can go down to this last one that says, what do I need to end up with? I need to find out 48 cups of fruit salad. So I'm going to figure out here. How many times does 3 go into 48? And whatever I can do to that bottom ratio, that bottom part of fruit salad, I'm going to do to bananas to find an equivalent ratio. So let's look. 3 goes into 4 one time. We have 1 remaining, and then we'll bring down our next place value. 3 goes into 18 6 times, and I'm left without a remainder. So my quotient here is 16. So if I multiply 3 times 16, I'll get 48. And because I know that if I can do it down here, I also can do it up here. So 2 times 16, if you can't do that straight out of your head, that's totally okay to write it down. 2 times 6 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. So I know I need 32 cups of bananas, right? So I am all done. I found my missing value, which is right here, the bananas. So I can go ahead and write Franco needs 32 cups of banana. Oh, that looks like a terrible. I'm trying to be fast here and made it look a little crazy. Sorry. 32 cups of banana. All right, let's keep going. A flower shop gives away bunches of flowers every year. Last year, the ratio was 25 flowers for every 125 kids. Based on this ratio, how many flowers will the shops give away if only 75 kids show up? So right away, I see I'm being compared bunches of flowers, right, to kids. So that's what I'm going to label it. So flowers to kids. Okay, and then I'm going to go ahead and put in the first ratio that I see. It said last year it was 25 flowers for every 125 kids. So now I'm going to make a friendly ratio. I know that 25 goes into 25, pretty easy. And then I know that 25 can also go into 125. I like to think about 25 as a quarter, like a coin, 25 cents. So 25 divided by 25 is 1. 125 divided by 25 is 5. Now that we have our friendly ratio, we're going to look and see, what do I need to end up with? Well, it tells me that I need to figure out, if only 75 kids show up, how many flowers are they giving away? So that means I need to look here. What did I multiply times 5 to get 75? And if I get that value, that means I can do it up here to make an equivalent ratio. So 75 divided by 5. 5 goes into 7 one time. With 2 remaining, bring down your next place value. 5 goes into 25 5 times evenly. So we have our quotient of 15. So that means I'm multiplying 15 by 5 to get 75. That means I can do the same thing up here. And because we made a friendly ratio, all we have to do is do 1 times 15, which is super doable. So we know that the flower shop is going to give away 15 bunches of flowers. Ta-da! All right, in the first week of October, and I noticed here that I had a misspell with my R. I forgot to put an R in October, so that's why it's ugly. All right, in the first weeks of October, there are 63 dogs. So I see dogs and cats. I'm going to just write this in as I'm reading it. As you get better at these, you'll see what you need to do as you're writing it. There are 63 dogs and 35 cats in a shelter. This ratio stays the same throughout the month. The last week of October, there are 15 cats left. How many dogs are there now? So I'm going to go ahead and put in my first ratio, which is 63 to 35. And then I know I'm going to need 2 spots. And then I want to end up with 15 cats. So I can just go ahead and fill that in. So first thing, let's make it friendly. Okay, so I've done that, and I'm going to make it friendly. What goes into both 63 and 35 that is the greatest factor that they have in common? I know that 7 can go into 63 and it also can go into 35. So 63 divided by 7 is 9, and 35 divided by 7 is 5. Now I can multiply easily, and I can see 5 times 3 makes 15, and because it's an equivalent ratio, whatever I do up here is going to make the same value. So 9 times 3, 27. Super doable. I have my answers straight away that I'm going to have 27 dogs left during that last week of October. And our last question, a wedding planner uses 42 daisies for every 18 centerpieces. So I'm going to put daisy and center. I'm just going to put centerpiece. We know it's centerpieces. So 42 daisies for every 18 centerpieces. Okay, then it says the wedding planner finds out there'll be more guests and they need to make 27 centerpieces. So we need to end up with 27. How many bunches of daisies will she need? So we need to figure out this value here. So first, we've already done this. We've drawn our ratio table and labeled it. We've put in our ratio. Now, let's go ahead and make this a friendly ratio. What am I going to divide it by? What goes into both 42 and 18? That's the greatest factor that they share. In one of my classes, someone said, well, 2 can go into 42 and 18. And that's true, but it's not the greatest amount. There are bigger values that can go both into 42 and 18. And to make this work the best, we need to find the biggest number. So 6 is one that goes in well. Okay, so 6 can be divided by 42 7 times, and 18 can be divided by 6 3 times. Now we can go ahead and figure out an equivalent ratio. So 3 goes into 27 9 times. So that means I can do the same thing up here. So 7 times 9 is 63. So now we can figure out, what do I need to end up with? How many bunches of daisies does she need? And we figured out that she needs 63 bunches of daisies. Okay, so the most important thing is that we need to be looking at these questions and asking ourselves these questions as we go through the problems. First, I need to draw a ratio table and label it. What are the 2 things that I'm comparing? Put in your original ratio. If it seems doable to you and you're good with your math facts, you can continue. But if not, you want to look and see, can I make my ratio more friendly? What are some numbers, some smaller digits that I'm more capable of using? And then finally, what do I need to end up with? What is the problem asking me to solve? Okay, and those guiding questions should help you to fill out your horizontal ratio table to find equivalent ratios.